Hello there, and welcome to everyone joining us for the latest IoT Central webinar. I'm Clive Maxfield, everyone calls me Max, and I'll be your host. In addition to being a practicing engineer, I also act as a technology consultant, author, speaker, and educator. I'd like to start our webinar by thanking Telit for sponsoring today's event. Telit is a leading supporter of the IoT Central community, and we're very grateful to have them as sponsors. Today's webinar is titled How to Calculate Overall Equipment Effectiveness and Maximize Manufacturing Production. The event will be 1 hour long. We will have one presenter who I'll introduce in just a moment. There'll be a Q&A session after the presentation. So now I'm very pleased to introduce today's speaker. Ricardo Buranello is Head of Platforms Business Unit at Telit. So whenever you're ready, Ricardo, you can take it away.
Hello, Max. Thank you so much for the invitation. Thank you so much, IoT Central. It is a big pleasure to be here and to be talking to you guys. My name is Ricardo Buranello, and I'm a Senior Vice President and Head of Telit IoT Platforms. And before we enter in the webinar per se, let me just give some context in terms of who Telit is and how we are helping some of the largest manufacturing companies in the world in terms of optimizing their manufacturing process by the adoption of IoT. Telit is a global company, and with our technology, we help companies from the different sectors in terms of implementing IoT. For you to understand the magnitude of our deployments, Telit currently connect more than 40 million new machines every year. That means a new machine, a new sensor being connected every second. So I think that we bring a lot of experience to the industry in terms of understanding the challenges and, most important, understanding how companies really can transform this technology in ROI, in return on investments, in impact, that what will change the reality for them. The technology that I will discuss here is a consequence of an acquisition. It's a technology that we started inside IBM back in the 80s as a product called PlantWorks. And in 2013, Telit acquired a spin-off of IBM Automation Group, a company called ILS Technology. And then we bring device-wise and secure-wise inside the Telit product portfolio. Our vision was that device-wise and secure-wise can become critical platforms, components to enable IoT to all the different types of industrial companies and industrial use cases. And we have been very happy in terms of how far this technology went. For you to have an idea, device-wise is currently present in 7 out of the 10 largest car makers in the world, in 10 out of the 20 largest tier 1 automotive companies in the world, in huge oil and gas companies, food and beverage companies like Coca-Cola and Hershey's, pharmaceutical companies like Johnson & Johnson, Abbott Labs, Allergan, GSK, and more. So we definitely see how IoT technology is being deployed in the real life of manufacturing and how this is changing the behavior, the way that things are done, and bringing higher productivity to this space. This technology won several awards as the Industrial IoT Product of the Year and is classified by ABI Research as a leader in smart manufacturing platforms. I really like the way that ABI Research describes device-wise, saying that compared to Kepler, device-wise has the advantage in lower latencies. Compared to Foghorn Systems, device-wise has more advanced IIoT integration capabilities. Compared to homegrown data extraction and edge intelligence solutions provided by industrial automation companies, device-wise has more flexibility and more advanced software. And they position us in the quadrant here as a leader in this space. But now that I gave a context in terms of who Telit is and what we do, I would like to discuss about the main topic here for this webinar. That is OEE. What is OEE? I think this three little words is something that we hear all the time. And OEE stands for Overall Equipment Effectiveness. And it's nothing more than a KPI, a key performance indicator used by industrial companies to calculate how efficiently they are manufacturing their things, their products. This is an indicator that is expressed as a percentage. So the closer you are to 100%, the higher is your productivity based on the standards that you have. That means, and you have three main components of this formula. That is the quality, the performance, and the availability. For the quality, it considers the manufactured parts that don't meet quality standards, including parts that need to rework. OEE quality is similar to the first pass yield that many companies they use, and it defines the good parts that pass through the manufacturing process without requiring to be reworked. That means if you manufacture the part, it was a good part since the very first process. So the higher your quality, the more efficient your process is being in terms of being accepted based on that specific standards. And what the performance means in this specific formula, it means that the performance indicator factors anything that is causing the manufacturing process to run at a suboptimal rate. It calculates how far your operation is from your best case scenario. You calculate what is your estimated time for this specific process, and is your machine or is your process as a whole in line with that best case scenario of manufacturing, or you are having delays in this process. And as you can imagine, these delays can come from multiple fronts, right? Maybe my machine is not moving as fast as it should because it needs to be recalibrated or adjusted. Maybe the process is being slower because the operators in between, they are not performing as fast as they could. Maybe the machine is available for you to run, but my raw materials are not ready. So you have some time of your machine waiting there until you have your parts ready. And this might be impacting your performance. And your availability. By availability, we consider all the events that stop the planned production. And it's calculated as a ratio of runtime to planned production time. The runtime planned production time minus the stop time is defined which the manufacturing process was intended to be running, but was not running due to unplanned or planned stops. So when your line is down, eventually it is down because of different reasons. Maybe it's down because I am setting up the line for a new part number to be produced. So that was a planned stop. Or maybe it's down because my machine is broken and now I need to stop this process until this is fixed. And this is certainly impacting my productivity there. By factoring these three different pillars for your OEE, you can calculate how close you are in terms of the effectiveness that is expected for your process. But as I said in the beginning, it is a very, very simple KPI. And that's not where companies will really bring the benefits of increasing their productivity. The benefit of increasing the productivity comes at the moment that you have a visibility of what is your overall effectiveness, and then you can start drilling down what is happening here on your performance. Just as an example, look at this table here, where on my first week I have 85% of OEE. On my second week, I have basically the same 85% of OEE. But you can see how different was week 1 to week 2 of performance. And this might give me reasons to better investigate my process and to improve my productivity on a consistent way by understanding what is impacting my effectiveness on a lower level. So for me, as a manager, as an executive, even more important than having a single indicator that is telling me how good or bad my operations is running right now is my ability of really drilling down on what happened there so I can keep improving my productivity. If you already saw one of my speeches here in IoT Central or in any other venue, I mention Paul Krugman, that is a very famous economist, and he has a very interesting phrase saying that productivity isn't everything, but in the long run, it is almost everything. So what will make companies to survive in the next couple of years is their ability of competing, their ability of bringing productivity to all the different sectors that they are, to all the different processes that they are, from industrial to commercial to innovation to finance. And looking at industrial, the more tools we have in terms of really bringing all sorts of data to your manufacturing, the better will be your performance and your ability of keep improving your operations. But other than this extremely simple algorithm, extremely simple formula that I just showed you, how do I really do it in a real life? In a real life, things are not just like a formula. If you walk on the shop floor, you're gonna see situations like this. A factory that will have different lines, different equipment. How can I really implement an IoT in a scenario like this? It starts on your ability of really identifying what are the key factors and machines that you have on the shop floor and how you can collect the data from these different equipment. But this also might be very complex, given the fact that these factories, they might have new equipment and old legacy equipment. They might have equipment manufactured in the United States, where you see a lot of Rockwell controllers, for example, but machines brought from Europe with Siemens controllers and CNCs and robots and AGVs and people, torque tools, sensors, every single one of these machines talking a different protocol. How can I collect the data from all these machines to know these machines are available or not? What is my cycle time? What is my productivity? That was a good or a bad part. How can I really collect all this data to start calculating this into a KPI? And when I come and I look at my IT space, I also see many different systems with different types of protocols and integrations, and everything running in kind of silos. The machines in one side not necessarily communicating to each other, and the IT systems also with a very manual input or completely isolated from the shop floor operations. The way that you can really optimize your manufacturing is by making sure that you have a complete integration between all your machines and all your IT systems with an intelligent layer of operations between them. At the moment that you really can solve this complexity of collecting all this data in real time, integrating these machines and these IT systems, providing real-time data visualization to managers and operators so they can understand what is their performance, this is the moment that you start to optimize your manufacturing. And the way that we do this is through an industrial IoT platform that is called deviceWISE. So deviceWISE is a software developed by Telit, actually started inside IBM, now under the Telit umbrella. And this software is a complete platform that allow manufacturing companies to integrate all these machines and all these IT systems with a layer of intelligence between them. With deviceWISE, the software comes with hundreds of drivers. So if you want to implement an OEE control, different types of manufacturing KPIs, you can use deviceWISE to ingest data from all these different devices. deviceWISE comes with hundreds of drivers. These drivers are written bare to the metal in order to guarantee real-time data connectivity to these machines. And with that, I can ingest data from literally any type of machine. If you have a new machine or a legacy machine, device-wise can be used for you to collect real-time data, for you to start calculating your OEE. So I can collect what is your availability, what is your quality, what is your process time, calculate your OEE. But even more than that, collect all the error messages, all the different aspects of your machines. What is my vibration, my temperature, and start to correlate all this data. All this data transformation, the KPI calculation, the math, the algorithms can be deployed in device-wise in a complete no-code environment. So you don't even need to write a single line of code. You don't need to have a software developer. You can collect this data and transform this data on the edge, calculating the OEE line by line, shift by shift, operator by operator, consolidating all this in your manufacturing line, and then integrating this with your IT systems. device can be integrated with SAP, with different types of MES systems like Dassault Apriso, Siemens Simatic IT, and more. Integrated with your SCADA systems, databases, relational or non-relational databases, cloud solutions like Amazon AWS, Microsoft Azure, and more. And device comes with a full HMI and dashboard system. So not only you can calculate your KPIs, but you also can create your front ends your for managers to see the full performance of your line, good parts versus bad parts, quality, yield, OEE, etc., providing all this information in real time. When you have the information in hands, then you can take actions. If the performance of my line this week is not doing good, I can drill down the reasons for that, and I can take corrective actions. So I can guarantee that I'm optimizing my resources, I'm improving my manufacturing process, and as a consequence, we are being more competitive in this industry. And what is interesting about our approach, these examples that I gave you, is how manufacturing companies are using device-wise, or how system integration companies are implementing device-wise to these end users, like automotive companies or food and beverage companies, for example. But there's also a complete new world that opens with the advent of IoT. That is connecting every single machine from the OEM aspect. So many of our customers, they are not end users, they are not manufacturing companies, but they are machine builders. They are companies that manufacture packaging machines, wrapping machines, plastic injection machines, CNCs, etc. And they sell these machines. Inside all these machines goes Telit technology in cellular gateways. So you can collect real-time data in terms of the machine performance, provide full data visualization with device-wise to the end user on the shop floor, but also using device-wise cloud so you can have an app and you can visualize all the machines that you have deployed all around the world. And this might be very powerful in terms of opening a new business model for these machine builders. Now, if I am selling CNCs and I have remote connectivity to my CNC, I can open a complete new business model. I can, instead of selling a piece of hardware and have a one-time fee revenue, I can sell a machine as a service and having a recurring revenue. I can calculate my OEE and I can demonstrate this to the end user, and I can collect the data and compare with the optimal scenario with the performance and come with recommendations to improve productivity of these machines. I can do preventive and predictive maintenance in a completely remote way, so people don't need to jump into airplanes and be in remote places where these machines are, but they can over internet, over with IoT, have this full connectivity to these devices. So we see this connected machine as the first step for a complete digital transformation. The same way that I personally see OEE only as a small component, but a critical component for you to go for a digital transformation, where the digital transformation comes not only in terms of the technology that you can deploy, but on the change of the mindset of managers, on how they see manufacturing and how they pursue effectiveness, how they pursue gains of productivity by really measuring every single step on their process. And the most interesting thing is how cost effective this solution can be, because now you have one single platform that is vertically integrated that can solve you all the problems for the deployment of a full manufacturing control. Our platform, deviceWISE, comes with all the different pillars for you to deploy this type of project. You have, if you are deploying a complete IoT project involving a OEE, you need to look at data collection. How can you collect data from different machines, from different brands with different types of protocols? How can you take this data and how you can transform this data on the edge? How can I calculate my OEE? How can I calculate my quality yield? How can I calculate my good parts versus bad parts? How can I make sure that I transform raw data in availability data so we can start having all these KPIs on the edge? How can I integrate this with my IT layer? How can I have data visualization, cloud connectors, remote access, and device management? So with one single platform, we can provide to our customers all the answers, all the tools for them to deploy this, providing a commonality layer. That means that we transform all the machines with different protocols and all the IT systems. We provide a real-time translation of all these protocols and making them talking to each other. At the moment that you deploy a project like that, you can clone it and deploy it line by line to multiple factories in a very fast way. And exactly because of the fact that we have this fully integrated, deviceWISE is by far the most cost-effective solution in the industry today. But if you're not using this and you're trying to deploy a project with different components, or I would say the old way, probably you will need many different software components to do this. So for example, on the data collection, eventually you can buy a CAP server and use an OPC server to collect the data. But now I am collecting the data from my controllers and I want to calculate how is my OEE for this specific machine. Kepler doesn't do that. You need to buy another piece of software, eventually Node-RED, for example, add some custom code there so you can integrate this. And then a manager comes and say, hey, I would like to have traceability. I would like to record all this data and to put this data in a SQL database or an Oracle database or an Access database. And I would like to open a ticket, for example, in IBM Maximo or SAP PM if my OEE is below a certain threshold. With deviceWISE, you can do this without writing a single line of code. You do 2 clicks, I calculate what is my OEE. I say if my OEE is above or below, let's say 80%, I want to send a ticket and open a ticket here for somebody to take a look at this specific machine. All this is solved with deviceWISE, while without deviceWISE, you need to have an army of people working on custom code. Do you want to have data visualization? deviceWISE comes with a full SCADA and HMI system called deviceWISE View, while without deviceWISE, eventually you need to invest in different types of applications like Ignition, like FactoryTalk and others. Do you want to have a data lake in the cloud? We can push all this data in real time to Azure, AWS, Google Cloud, and you name it. Without deviceWISE, you need to have more custom code there. Remote access, especially on the example that I gave for OEMs, for connected machines, deviceWISE comes with all the security around to guarantee secure remote access to manufacturing environments and remote machines. Without it, there are more components that are needed, as well as all the device management. So the way that we personally see the benefits of using a smart manufacturing platforms is creating a common layer with all the different tools that, even though every factory is different from each other, it commonizes this environment, making the engineers that work in this factory, the software um, engineers, really able to create all these KPIs calculations, all these machine connectivities in a much faster way. So not only you can think a platform like this as a way for you to calculate your OEE, but for you to do the complete digital transformation. So here I can give you a few examples of of some of the customers that we attended and how we supported them on this journey. So as I mentioned, everything starts on your ability of really collecting process data for you to start thinking in terms of your digital transformation. So how can I collect process data if I have 100 different drivers needed on my shop floor, if I have different machines, if I have islands of information and places that I can't really know what's going on until somebody comes here with an information. So the typical way that most of you already saw are Excel running everywhere, managers not totally sure in terms of what is going on until you have a fire and everybody starts to run after to solve the problems. By having a transparent layer of communication, you can collect data from PLCs, from robots, take data from barcode, RFIDs, and other sensors, integrate these process with laser cutting machines and CNCs, torque guns and other types of tools, and even using cameras as a sensor for you to collect quality data, for example, or other types of data coming from the operators, like an input from a tablet, for example. So we solve all this machine connectivity, and we can have all this integration with all the different types of legacy systems that customers have. So what is the journey that we see from our customers there on this digital transformation? We see many of our customers starting with integration and automation. So imagine the following. I've been to one of the largest health devices manufactured in the world, and they invited us for a project that the objective was to integrate a CNC line with a quality control that was manually operated, but they would like to add a robot there. So the way that we integrated this project was the following. In that specific line, we made device-wise to talk to a Fanuc robot and a Siemens CNC. So device-wise started to command the robot. So in a very simple way, we can set up device-wise to say, robot, it's the CNC is ready, go there and drop the part to be cut. When the part is in there, device-wise can start the process. When the part is cut, device-wise can tell the robot again, now pick the part, put in a quality control system. Device-wise can go to this quality control system that is a prober tool that measures all the parts, see if this is a good part or a bad part. And not only this, but also take an action, for example, like writing the offset on the CNC to recalibrate the CNC right after every single process. In this example that I gave you, we started by making a robot to talk to a CNC, to talk to a quality control system, so making machines to talk to machines, a typical industrial integration here. All this done without writing a single line of code. And then when I was in this customer that we integrated these parts, one of the questions that I asked them was, okay, we all know that unplanned downtime is one of the biggest villains for OEE, for performance. How do you make sure that you don't have machines going down because of lack of maintenance, for example? And they said, well, I'm not sure if I do it. I have one person that walks around with a piece of paper. He looks at the HMIs. He sees how many cycles this machine went through, and then he calculates in the Excel when they should calibrate these machines, and then they open in SAP PM a ticket for maintenance of this machine. I said, okay, if we are in 2022, I think that we can do better than that using IoT technology. Why don't we take your smart manufacturing platform that is already there, integrating the robot and the CNC? Why don't we calculate how many cycles this machine went through? Based on the manual of this machine, I can say if this is approaching the number of cycles that that you need to recalibrate your machine, then let's open a ticket directly. And then we implemented this project. And believe it or not, that project took a morning to be implemented, one morning, because all the tools are there. You just set up what is the logic that you want. And then we even went further. We said, okay, not only I want to calculate number of cycles, but I also want to calculate what is the power consumption, my vibration, my temperature, my quality yield of this machine, because if my quality starts to go down, then it's telling me that somebody needs to look at this machine. Or if the cycle times, even inside the machines, in terms of the motions of this machine, is taking longer, that means that I have hidden downtime inside the machine, even when the machine is active. So we implemented all this predictive maintenance also inside deviceWISE, also without the necessity of writing a single line of code, already impacting the OEE and the performance of this line. All the quality control can be implemented using different types of instrumentations. Do you have quality lines that you have people testing products or jigs testing products? We can ingest this data. Or do you have quality done by operators doing the quality tests? You also can put a tablet at the end of the line, ingesting the data into your system in order for you to calculate your OEE and your effectiveness. And one very interesting thing that we developed was a full integration of deviceWISE with a visual inspection system. And that's a product that we called deviceWISE VI for visual inspection, where not only I bring the data from the robots and the POCs natively, but I also can use cameras as sensors. That means that with a simple camera at the end of the line, I can take pictures of the products. I can say this is a good product or a bad product, and I can separate the good products from the bad products in batches. Not only I can do the quality separation, but also I can ingest this data into my system and provide all the visualization for managers. And you can see how much I stress on visualization and on real-time data, because I think this is the trigger for actions. At the end, the machines and the IoT, they're not here to replace people. They're here to make people work better and smarter by giving the right types of insights so decisions can be taken on the shop floor and quality and performance can be improved. And then we can have all these IT and OT integration and the usage of artificial intelligence for you to integrate it to any type of cognitive platform and AI. So it is one single platform, but the possibilities that you have in terms of really driving your business for a digital transformation, this is huge. And this is where people really should aim their investments, because this will guarantee their future. This is a very interesting use case that I would like to share with you. And that is the largest electronic manufacturer in the world. That is a factory that I had the chance to visit in China, where we deployed our technology there. This factory is producing all different types of things, everything that you can imagine. But this line specifically is a line producing cartridges for ink printers. And in this line, we had a couple of challenges there. The customer had a vision that was, I want to have a digital twin of my factory. If we are in 2022 today, the moment that we deployed was beginning of 21, this project, they said the operations of the future will include digital representation of my process. I need to have a control room for every single machine, and I need to be able to see the state of this machine. With one click, I need to be able to see historical data of this machine to understand trending. With one click, I need to see the combination of these different components in my line for a full process and see good parts and bad parts, actual versus forecast, OEE, quality, and more. And then they came to us and said, how can you help us? And we said, I think that you need one software. And only with deviceWISE, nothing else needed here, we deployed this full project for them. But that was also challenging because of the nature of that specific process. This was, one of the most impressive factories that I've been in my life. And I spent the last 20 years of my life visiting factories and shop floors. The lines there are incredibly fast. So with the super high speed transactions, it is challenging for you to collect data fast enough. If you understand a little bit about control systems and PLCs, you understand that the way that the PLCs, they log data in the formats of the tags. But every time that this data goes through, they erase this data and record the new data. And with the major objective of this controller is to control the machine, is to be effective. So you need to have a highly efficient software for you to collect data fast enough from these controllers. And this specific customer, they tried many different softwares. They tried Ignition, they tried Capper, and they failed exactly because of the high latency of this technology. And as I mentioned already in the beginning, the way that we here in Telit, we write our drivers. We write our drivers in a very low level language. We write them in NCC in order bare to the metal in order to guarantee that data can be collected in real time. This is important for multiple reasons. For OEE calculations, for example, it is important for the reliability of your data. So you don't lose data when you are trying to capture this data. Or also important for you not to create unexpected downtimes. Imagine that I will not allow a certain machine to do something until I receive a beat in my system. What is very common, for example, in the industrial space, where for you to manufacture, if you are in a car making process, before a certain machine starts a movement, you need to record the VIN number. If your system is taking half of a second to pass this information of the VIN number, that means half of a second of a downtime. Who cares about half of a second? Repeat this 1,000 times, and you will care a lot about half of a second, because this means a downtime here. This means that your OE will be significantly impacted just because of the latency of your system. You will manufacture less parts at the end of your cycle. So with a real-time data as data management system as device-wise, we can overcome this challenge. And then we could have all the deployment there. The second challenge that we had was the diversity of equipment. In this line, it was in China, but we had equipment imported from United States with Rockwell controllers. And we had quality systems imported from Japan with Mitsubishi controllers. And we had local machines developed in China with Chinese controllers, every single one of them talking a different language. So they were not, it was not possible for them to intercommunicate the data of these devices. At the moment that we implemented device-wise does all the protocol translation. And now I have all the harmonization of this data. I have a transparent layer of data. Doesn't matter what is the controller that you have in this machine. All the data is available for me in real time. And then creativity comes. The way that you can create a control room like this, you can just drag and drop the widgets, right click, point to the variable that you want, or use an algorithm inside device-wise, no code, for you to calculate different types of KPIs. And now with the data, we can create any type of chart of dashboard that you can imagine. No code needed. The way that I explain this to to customers and to partners that we have is, imagine like a PowerPoint for machines that allow managers to define what is important for them, drag and drop a widget, and have a real-time data coming from their lines. And also important, in a world that moves and changes so fast, the ability that you have in terms of changing your process and updating your system without investment. Imagine that you do a complete digital transformation project like this. Really cool project, right? That you have the digital twin and all the KPIs, and then 1 month after, somebody say, hey, I need to change that specific machine over there. I need to change the layout of my line. How do? You throw everything away. No, with deviceWISE, as this is a complete no-code platform, it is literally like updating a PowerPoint. Just change what was changed in your real life, appoint to the new machines, and now all the data can be available. This is the way that we would like to share our vision of the future in terms of how to integrate this. The important takeaways of this session is information is important, management is important, and connectivity is real at the moment that we are. Don't reinvent the wheel. Go for the basics, but make sure that 100% of your manufacturing process is properly logged and data is available for you to change. If I manage a manufacturing line as I managed for years and years in Telit, it was always very important for me to have statistical data in terms of how efficiently my line is running. So it starts with collecting the data, creating KPIs that make sense for you and for your process. It is not a magic formula. It is just one indicator for humans really to take management actions here and fix the things. Calculate your KPI, have real-time dashboarding for every single person that works in that specific factory, so they understand how well or how poorly this line is going through, and you can have inputs from different people. Pay attention to the details. Make sure that you don't have islands of information there, that you really can have across all your shop floor data flowing so creativity they can come. And pay attention also to the details. Don't simply look at one KPI and say this is good or this is bad, but make sure that you have the ability of really drill down all the details of why my OEE today is 85% and last week was 85.7%, and what changed here and how I can fix my root causes in a consistent way. Keep pursuing optimization of your shop floor. Keep an eye in terms of the reduction of planned downtime. Making sure that you can have quicker setups, it's important for you. Making sure that you have quicker calibrations and stops on your line is important, that you always keep track of that. And you have a good dashboard to show what are these planned downtimes, if the team is performing according to the expectations or not. And also keep an eye on your unscheduled downtime, on the unplanned downtime. How can I know that this line is down? If this line is down, how can I create quicker actions to the people so they can fix these problems faster? One of the things that I see as a big trend for the customers that they deploy deviceWISE as an industrial IoT platform is integrating deviceWISE with end-on displays. That could be the old type of end-on displays that we know, or modern large screens, TVs on the shop floor that will show me the messaging system there. My line is down. I need somebody to look at this. Create visual alerts and measure this. Downtime, sometimes it will also require you the ability of drilling down the details of this downtime. And that is one of the examples that I gave in terms of how the latency can be critical for your operation. Understand the downtime of your machine, but also look in every single motion of your machine. And then you really need to have a great machine data collection system there that will provide you not only how many good parts I produced on this machine at the end of my shift, but also how fast all the motions are inside of this machine, so I can optimize this process, reducing the manufacturing time cycle that I have for every single machine. And of course, keep an eye in terms of your quality and rejects. Make sure that you have a good control on that, historical control, and you keep optimizing your process. So for me, OEE is indeed a very important KPI, but at the end, just one of many KPIs that you need in order to have a real digital transformation. I believe on the technology, and I believe that the technology will define the competitive companies in the future, the competitive countries in the future, and will provide to all of us better life standards. This is how we can optimize the resources that we use, how we can have a greener planet with more wealth being distributed to people. It is the technology helping people in terms of really having better lives. So if we keep looking at this and pursuing, quality standards, productivity standards, I'm pretty sure that we will have a better society in the future. Guys, I really would like to thank you so much for IoT Central to have me here. And I believe that we still have a couple of minutes. So I'll be very happy to answer any questions that you have. If you have further questions, please feel free to type here at the chat, and I'll be very happy to respond as many questions as I can before our time is over. Thank you so much.
Well, thank you, Ricardo. In fact, my own degree is in control engineering. And when I think back to the way things were when I started my career, what you're doing today is absolutely amazing. Okay, so now it's time for our question and answer session. We've got some great audience questions that have been coming in throughout the presentation. And I encourage anyone to send in any last minute questions. Even if we don't get time to answer them here, Ricardo will follow up later. Here's the first one, Ricardo. With a project like the one you showed in your example in this webinar, can you really do everything in device-wise, or do you need to use other software packages also?
Thank you so much for the question. Yes, I think the idea of device-wise is really be a completely vertically integrated platform. So you can have one single source of truth. And I would say that yes, absolutely, you can have everything running in one single platform that is device-wise. So I would say that if your company is in stage 0, what do I call stage 0? My machines are not connected. I don't have any KPIs calculation other than eventually something that is done basically on Excel spreadsheets. I don't have any data visualization. All the line setup is not done through an MES, but it's done manually according to my production planning process. I would say that yes, you will probably not need anything else other than device-wise because of our ability of collecting data from all the different machines with our extremely extensive list of drivers. So you can transform all this data and calculate what is important for you for KPIs like OEE, for quality control, for preventive and predictive maintenance, and you name it. And you can integrate this with IT systems and have all the data visualization as the example that I show, creating all the sexy dashboards and screens for you to visualize real-time data from your process. But you also can imagine that many of the people that are here listening are also working for very large companies. And what is very normal in a very large company is that you're going to have different legacy systems and legacy machines. And what I like in terms of our approach, our methodology of doing digital transformation for customers is we don't throw away things that are working and things that are good. So if the company has a good MES system, I can integrate with this MES system and I can augment the capability of this MES system by doing the machine integration. If they have track and trace systems for traceability, we can collect all the data from the machines, from different sensors, and ingest in this track and trace system so we can optimize the systems you have. Do you have MRP? Do you have ERP? We can integrate to SAP, we can integrate to Oracle, we can integrate to IBM Maximo. So I think it depends a lot on the stage that companies are on this digital transformation, on this journey. But certainly you can do the full OEE calculation with device-wise, or in more complex, sophisticated types of use cases, you still might have different softwares there, but with an intelligent and transparent layer of information that is device-wise that will make this integration among different machines and different IT systems.
Okay. So when I first read this question, I was like, because is this solution scalable? Can I use it for both small and large customers? And I thought, well, that's pretty obvious because we can see that we can use it for the largest customers going. But then I thought, if you turn it round, in addition to these humongous customers, can you use it for a small customer?
It's an interesting question, Max, and I would say yes. The way that we license device-wise is thinking in terms of an impactful platform for all the Fortune 500 companies, but also for small companies out there. To tell you the truth, currently most of our customers, they are big multinational firms, companies like Ford, like Honda, like Coke, like Johnson and Johnson. But still, we have small companies, like companies with 40 employees, 30 employees manufacturing things. And the license is very scalable the way that we commercialize it, because it is based on connections. So I can buy a package for 20 machines, or I can buy a package for 2,000 machines. And it is completely scalable in a way that even if I have a small mom and pop shop with 5 CNCs, I still can deploy this technology, and I can have a digital factory even in a small scale customer like that by using the same software, for example, that is used by Ford or John Deere or Caterpillar, that is device-wise.
Cool. Somebody says, can I use device-wise as an HMI replacement?
Absolutely. device-wise is a full HMI and SCADA system. And the dashboards that you saw in that project that we did in China, all these is a no-code platform that you can use to create any type of screen that you want. And it's very interesting because it is a responsive platform for any type of screen. I can make literally any type of screen, of TV, of tablet, of phone, as a screen for my system for different purposes. If I have my CEO and my CEO wants to see how the line is performing, I can put a TV on his office showing in real time how the line is going on. But I also can put tablets in front of every single machine. Imagine that you have a machine that is 30 years old, and you can have now a tablet showing how this 30 years old machine is performing in real time, because we are ingesting this data, showing a dashboard with all the graphs on how this machine is performing. And eventually, not even this, use this as a real HMI where I can put buttons, have a bi-directional communication, and now I can put the operator to push one button and turn on the machine, push another button, and select the preset of this machine. Or if my machine is down, I might say, hey, go there and classify this downtime. Yeah, I might know based on the PLC message, but eventually there's something else that only the operator on the line, they are able to tell. My line is down because the line is starving, or my line is down because I need a bio break, and I can push this button, and then I can ingest this data coming from these different sources. So a straightforward answer, absolutely. Device-wise view is a full HMI and SCADA system.
Awesome. Another question. If I have machines that are not controlled by PLCs, are there any other data ingestion methods?
That's an interesting question, and the answer is yes. I can give you an answer to this based on a real use case. And I even feel comfortable in terms of saying the name of the customer, given the fact that we had a joint webinar. If you're interested, you can even take a look at the YouTube and you're gonna find. The customer is AAM, American Axle. American Axle is one of the largest tier 1 companies in the world, an American company, and they use deviceWISE in dozens and dozens of factories that they have all around the world. And they started deploying deviceWISE in a super large scale. I think they have more than 4,500 machines connected today with deviceWISE. At the end of the first phase of the project, they said, all my connectable machines are connected. All the machines that are PLC driven, that are CNCs with controllers, that I can just pick the driver and have the data coming in, they are connected. But I still have this machine here that is a 45 years old CNC machine, and the machine refuses to break and is still used on the manufacturing process. How can I ingest data from this machine that the only thing that this machine has is an IO telling me the state of the machine? And we came with an answer. So we have a hardware adapter that we call it Smart IO. This hardware adapter can translate electrical signals and other types of inputs like digital and analog inputs, sensors, etc., into data inside deviceWISE. So I can simply wire up on the IOs of this machine. If every good part I have a pulse in a certain IO, if I have another IO telling me the state of the machine, and if I can use a transducer to read, for example, the power consumption of this machine, guess what? I have all the variables necessary to calculate the OEE that we were talking here. So you can do all this instrumentation, collecting the data from these machines or using external sensors or even cameras at the end of the line, really being able to ingest data from old legacy machines that eventually are not controlled by PLCs or CNCs.
Okay, now this question, it's either by somebody who came in late or who wasn't paying attention in the middle. If I use deviceWISE, can I replace Kepware? What about a SCADA system like Ignition? And I know the answer to this one, but I'll let you give it.
Yes, the answer is yes. So deviceWISE replaces completely the necessity of any OPC server like Ignition. By the way, we have all the OPC drivers as well, OPCDA, OPC UA, client and server, for you to read, ingest, or externalize data as in an OPC format, or using the native drivers that we have for Siemens, Rockwell, Mitsubishi, Orman, Yaskawa, and you name it. We are talking about more than 325 different drivers for you to ingest data from any type of device. And yes, we can replace, but the replacement is interesting for a couple of reasons. The first one is, yeah, I'm saving money, right? So I have one platform here. I don't need to have Ignition. I don't need to have Kepware. I have just one platform. So certainly will save you money. But the second reason is the simplification of the architecture. I have a much leaner architecture here with one single point of failure. I know exactly where it came, where it went with deviceWISE. I am not creating a Frankenstein of software on top of software on top of software with multiple points of failure there. So you can replace all this with one single platform. But you also might ask me, and I can give you real life examples. I know how powerful an Ignition software can be. It is expensive. It is very it demands a lot of time and effort for you to do all the customization and the integration. But yes, it can be very useful for any industrial company, no doubt about it. What happens if you already did this investment and if you already have Ignition running as a SCADA system there? There's no problem at all. You can use deviceWISE to do all the intelligence of data collection, edge transformation, KPIs calculation, OEE, etc., and ingest, for example, the data into your SCADA system, making sure that you don't need to throw away something that is working, that is your SCADA system. So you can have a simple architecture with deviceWISE doing all the data collection, transformation, visualization, and integration, or use this more as a middleware integrating with different components that you have.
Okay, excellent. Well, I think we've got time for just one more question. And while I ask this last question, Ricardo has told me that you can feel free to contact him directly using the
Absolutely.
contact details shown on the screen. So this final question, and this is one of those how long is a piece of string questions. How long does it take for a manufacturing company to deploy a solution like deviceWISE?
Good question. I think that, it varies a lot in terms of what you are trying to achieve. And I keep repeating something that I don't want to use journey as just a silly word, but I want to use journey in terms of a mindset, in terms of a management mindset there. For me, digital transformation is a journey. It is not something that you begin today and you finish in 2 months. It is changing the way that you perform. So I think that companies, they will always use deviceWISE and they will always be improving their systems. But let me answer this on a more practical way. If you want to collect data from a machine, calculate the OEE and display this data, I'm pretty sure that a trained person can do this in between 1 and 3 or 4 weeks. It will depend on the number of machines, the complexity of the data and the charts that you will deploy, but it can be done in a very quick way. You begin today, before the end of the month, you're going to be done.
Awesome. Again, I'm thinking back to my days in a factory. This would have made my life so much easier.
Absolutely.
Okay, so thanks to the audience for the questions and to Ricardo for his insights. For those of you who posted questions that weren't answered, we'll forward any of the remaining questions to Ricardo so he can follow up later. This event's being recorded and will be available for on-demand viewing starting tomorrow, where it will be found on IoT Central at iotcentral.io. And that brings today's webinar to a close. So I'd like to thank everyone for attending and for your thoughtful questions, and a special thanks once again to Telit for their sponsorship, and especially to Ricardo for his insightful presentation. Once again, this is Clive Maxfield. I'm very pleased to have been your host for today's event. I look forward to seeing you again on the next IoT Central webinar. And until then, from all of us here at IoT Central, we hope you have a wonderful rest of the day.